We all love the idea of planting trees to fight climate change, right? It feels hopeful, tangible.
It really does.
Huh.
But, here's where it gets a bit more complex.
Yeah. How so?
Well, not all tree planting is created equal.
Hmm.
That simple act of planting a tree actually hides a surprising amount of, well, nuance.
And understanding that nuance is key for effective climate action.
Exactly, if we really want it to work.
Okay. So today on the deep dive, we're digging into a difference that often gets maybe glossed over: reforestation versus afforestation.
That's the one. It's about moving past those easy headlines, to really get what works and why.
Because these aren't just fancy words, are they?
Not at all. They're fundamentally different processes. It all comes down to the land's history. That's what really shapes the climate impact and the ecological side of things.
Okay, land history. Let's unpack that. What is the actual difference then? Reforestation first.
Right. So reforestation is all about restoration. You're establishing forests on land that used to have them. Maybe it was cleared for farming or logged and degraded.
Ah, so you're bringing back what was lost, like fixing a mistake almost.
Kind of, yeah.
Yeah.
You're aiming to recover those lost ecosystem functions, get that carbon back into the system, returning a field that was once forest back towards its original state.
Got it. So that's reforestation, bringing back the old. What about afforestation? That sounds like starting something new.
Precisely. Afforestation is creation, planting new forests where they haven't historically been, at least not for a long time, say 50 years or more. That's the benchmark the UNFCCC uses,
UNFCCC.
the UN Framework Convention on Climate Change. They set a lot of these global standards.
Okay. So afforestation isn't restoring, it's like writing a whole new ecological story for that land.
You got it. Creating a novel ecosystem from scratch.
So the big question, carbon. We hear trees suck up CO2. Is it the same deal for both methods?
Well, yes and no. Both approaches mean trees grow, storing carbon in their biomass trunks, branches, roots. Tropical areas are champs at this, maybe up to 8 tons of carbon per hectare per year.
Okay, sounds good so far. Where's the catch?
The catch is under your feet. The soil. This is where it gets really interesting and honestly quite counterintuitive.
The soil. I always pictured the carbon being mostly in the trees themselves.
That's a common thought. But soils actually hold more carbon than the atmosphere and all the plants on Earth combined. It's a massive reservoir.
Whoa. Okay, so how does reforestation affect soil carbon?
Reforestation generally helps. It directly restores soil carbon that was lost when the original forest was cleared or the land was farmed. You're basically repaying a historical soil carbon debt. Studies show it can recover pretty quickly sometimes.
Okay, that makes sense. Restoring the forest helps restore the soil. What about afforestation then? Does planting trees on, say, grasslands also build up soil carbon?
And here's the paradox. On lands that already have high carbon soils, think native grasslands, or especially peatlands, planting trees can actually cause a net release of that stored carbon.
Wait, release? How?
Disturbing the soil to plant the trees, plus the changes in the ecosystem, can unlock that stable soil carbon. So you might see trees growing, looking like a success.
But you could actually be losing more carbon from the soil than the trees are taking up.
Exactly. For decades, even. Visible gains above ground, hiding invisible but critical losses below.
It's a huge risk.
Yeah, that's a big deal. Okay, what about the types of trees? Lots of projects use those fast-growing single-species plantations, right?
They do. It's common. About 45% of global reforestation actually uses these monocultures, just one type of tree.
Is that bad?
It carries big risks. Sure, they might grow fast initially, but ecologically they're very fragile. Think about it. One disease, one pest, one type of drought stress can potentially wipe out huge areas. They're also more vulnerable to fire.
Right. Less variety means less resilience.
Totally.
Yeah.
China's Green for Green program is an example. They used a lot of monocultures, and studies found it actually led to net losses in bird and bee diversity in some areas.
So monocultures are risky. What's the alternative? Planting lots of different types.
Yes. Diverse native species plantings. They're far more resilient to climate change impacts, and crucially, they store significantly more carbon in the long run. More carbon with diversity. How much more?
Some research shows stands with just 4 native species can store over 4 times more carbon than your average monoculture. It's pretty amazing.
Wow. So what's good for biodiversity is actually better for carbon storage, too.
That's the powerful connection, yeah?
Okay, thinking bigger picture now. These huge tree planting ambitions must bump up against other things, right? Like, where does all the land come from? Competition with farming.
Absolutely a major issue. Some of these really ambitious afforestation goals Could require massive areas, maybe up to 1.1 billion hectares globally. That puts forestry squarely in competition with agriculture.
Which could mean?
Potential impacts on food prices, food security. It's a serious trade-off we have to consider.
And water, too, right? Trees need water, a lot of it.
They definitely do, much more than grasses or crops typically.
Okay.
Through something called evapotranspiration, basically. Trees breathing out water vapor.
So large-scale afforestation, especially somewhere dry?
Can drastically reduce water availability downstream. Average reduction in water runoff from afforested grasslands is around 44%. We've seen links between large tree planting projects and water shortages in places like China, another big trade-off.
Okay, one more effect you mentioned, cold places, something about reflection, albedo.
Right, the albedo effect.
Mm.
Shiny surfaces like snow or ice reflect sunlight back into space, keeping things cool. Dark forests, on the other hand, absorb that solar heat.
So planting forests in snowy northern regions
Can actually lead to localized warming, which might cancel out or even outweigh the cooling benefit from the carbon the trees absorb. It can make afforestation there counterproductive for the climate.
Okay, this is a lot more complicated than just plant more trees. So how should we think about this? What's the hierarchy for climate action using trees?
Yeah, it really demands a more thoughtful approach. The absolute top priority.
Protect what's already there.
Exactly. Existing, intact, mature forests. They are our biggest, most stable carbon stores on land. Preventing those emissions by stopping deforestation is always, always more effective than trying to recapture carbon later.
Okay, protect first. What's next?
Second, restore. Focus on ecological reforestation. Bring back diverse native forests on land that used to be forest, especially degraded areas or abandoned farmland. Let nature regenerate where possible, or actively plant mixed native species.
Makes sense. Restore was lost. Carefully. And afforestation, where does that fit?
That's the third priority, and it needs extreme caution. It should really be the last resort, only considered on land that's verifiably low in existing carbon, so definitely not native grasslands or peatlands, and low in biodiversity value.
And even then, lots of checks.
Absolutely. Strict prohibitions on converting those high-carbon ecosystems, mandatory impact assessments looking at water, food security, local community rights. It has to be done incredibly carefully, if at all.
So the big takeaway seems pretty clear then. Reforestation, when done right, focusing on restoring diverse native ecosystems, is generally the much better, more resilient climate strategy.
Definitely. Afforestation looks appealing, but it carries these significant risks, often hidden ones, that can make it counterproductive if we're not extremely careful.
Which really leaves a final thought for you, the listener. Planting a tree sounds simple, but it's a complex climate solution. So the question becomes, how can you tell the difference between genuinely effective nature-based solutions and the ones that might, unintentionally, do more harm than good?